My talk today is about our paper titled Performance Benefits of High-Fidelity Passive Haptic Feedback in Virtual Reality Training. And as he said, I'm Anton Franzluebbers, and I worked with Kyle Johnsen on this paper. So currently, when you want to create a simulation of a golfing experience with a commercial headset, you would generally have a controller that is tracked, obviously, and a virtual putter that would then be mapped to that controller, and you could then hit a ball in a virtual environment. But one area where we can help to improve this is by using passive haptics. So passive haptics have had commercial successes in the past. For example, on the Nintendo Wii console a while ago, there are plenty of accessories that you can attach to the remotes that would change the physical appearance and how it feels in your hand. So if you see on the right, there's a wheel that would then that you would change the way you hold the remote, but it doesn't actually change the way it works at all. It still thinks that it's just a remote, but it can change the way you use it. So some of these are just maybe more for visual sake. So the tennis racket and the golf club are not a full size or full weight, and that's something that can change with different passive haptic props. You can increase the fidelity by by changing the texture of the object. Maybe that's the important thing that you're trying to simulate, or maybe the mass as well, or the weight distribution, or maybe different things like utility by the shape of it, so you can touch other objects in your environment, as our golf club will do. So mass is really important. So previous work has focused, for example, one device that was created was Shifty by Zenner et al., which focuses on the inertial properties of the device that you're holding. So it has a movable mass within a tube that can change the moment of inertia compared to match the object that you're trying to simulate holding. Another similar simulators to what we're developing is Table Tennis Simulator by Freeman et al., which used a table tennis paddle that you would hold that was also tracked, and also just the handle of the table tennis racket, and to see what differences they could find there. They found an increase in preference for the more realistic props, but they did not find an increase in performance in the task that they were doing. A similar thing more recently was Reinhardt et al. With their tennis game, where they had an actual tennis racket or tennis-shaped racket that also had just a handle version as well, and they found similar results. They didn't find an increase in performance. So we think we can find an increase in performance, but why would we think that when these previous studies haven't found that? So there's some properties of the club that we think are really important to creating a significant difference in the performance of a passive haptic prop versus just a smaller device like a controller. So the club is pretty long and heavy, which gives it this significant difference to just holding a controller. Also has a non-uniform mass distribution with a lot of mass concentrated near the end of the club. So it will greatly increase the moment of inertia compared to just a tube, as well as the utility between the floor and the putter position. So since it's long, it will touch the floor, and that actually helps you use the device better because you can rest it on the floor, which will help you with the angle of the putter, as well as aligning your head of the club with the ball. So in a virtual putting game, you could often just intersect the club head with the ground, and you would actually, when you swing, you go below the ball, which causes you to miss the ball. Whereas this, you can't do that because it's hitting the ground. So important for our application is that it's striking the ball is mostly felt as a vibration rather than a feedback loop that will actually change the way the ball is hit. So we can just attach a vibration motor to it, and then it'll give a pretty realistic experience in terms of what it feels like to hit the ball. So our question for this is, how will a physical prop like a putter increase performance in this kind of application? So first of all, we have to mount the controller to a putter, or track the putter in some way. So our first experiments used a Vive tracker, but it came out kind of clunky because we wanted to add a vibration motor as well, which the Vive tracker doesn't have, and also inputs and stuff like that would cause a lot of wires to go around, and it was a lot harder to attach. So the system we ended up on is pretty elegant and easier to attach. Basically, there's some cheap components, as you see on the left, that with a 3D printed mount in orange on the picture, just by attaching a few zip ties, you can pretty easily attach and remove the Oculus remote pretty easily. And so as you can see, we did use a Oculus Rift CV1 for our thing with a TP-cast wireless system. The wireless system is actually pretty important for this because when you're bending down to do a putting task, the wire really gets in the way. So it was really good for our application. So then once we had the attachment, we created a virtual model of the putter and just matched the two. The head looks a little bit angled here, but it's just a camera perspective. The models are pretty accurate to the real putter. This way, just the virtual putter, wherever you see it in the virtual world, that's where it is in the real world as well. So now this is what the application looks like. So the middle picture, the left picture is what you saw earlier. The middle one is now that we have a tracked putter. So now it's the same thing, same experience in the virtual world, but it has a tracked putter to improve the experience. On the right, then, you can see what it would look like in the real world. So we have a top-down camera, so we could compare the same experience in the real world, which previous papers haven't done. So we could compare the performance in the real world to the performance in the virtual experiment that we had. Okay, so for our study, we decided on two condition within subjects crossover design. So we split all the participants into two groups based on which condition they tried out first. So on the left, you can see the controller condition and putter condition on the right. So those are the two groups that we had. So those are the groups that we did. So each group either tried the controller condition first by first doing 9 practice shots so they could get used to the system. Not necessarily to practice how to do golf, but to practice what the controller would feel like and how they would use it. And then they would take 18 test shots where we actually where you use the data from to analyze their performance. And then they switched over to the other condition, and then they did the same thing again. And then afterwards, they took 6 real-world shots to compare it as a baseline. And then we also had a few surveys before and after to measure their opinions on the system and their background information. So our hypotheses were that the putter will be subjectively better, and we'll determine that by the surveys and the reviews of what the people think, and also that it will be objectively better in that the performance will increase by using a putter. And then we'll measure that by measuring the final vector from the ball to the target, basically a single hit, how far then was the ball from the target that they were trying to aim for. And also we'll think that the putter will be closer to real life. So we'll think that there'll be a greater correlation between the putter condition and the real condition compared to the putter and compared to the real condition and the controller condition. So we think that there'll be a greater association between those two. So here's our virtual environment for the practice area. You can see it looks kind of like a mini golf course. This is just for getting used to how to use the controller. And so there's 3 different holes at different distances, so they can practice the full range of what the ball will respond when they hit it. So there's one that's kind of at a 90-degree angle, so it has to bounce off a wall. This one you actually have to hit it pretty hard. That we did it on purpose so that they could experience what the ball would respond if they hit it pretty hard. That's harder than they would have to hit it in the actual testing environment. On the right, we can see it's just an open area with a target and the ball, which is the testing area. So we had 3 distances. We had 150 centimeters, we had 300 centimeters, and 600 centimeters. And so they did 3 on each position, and then they did the 3 on each position again, so for a total of 18 shots in each environment. And every time they switched distances, the starting position of the ball moved a little bit as well, so they wouldn't get used to just hitting the ball in the same direction every time, so they couldn't just get into the rhythm and remember their previous shot. And instead, they actually had to think about the power that they're using. And that's also the reason why we split up each distance into 2 sections, so that they would kind of not get used to that particular shot and instead have to concentrate on the actual controller that they're using. Then we also had the real-world environment with a top-down camera, so we could track the ball position, and so we could then measure the position of the ball, the final position of the ball relative to the hole, just like we did in the virtual environments. So for our population of the study, we had 20 participants from the local student and staff population. Their average age was about 23.8 years, and we had 18 male and 2 female participants. They had a variety of gaming and golfing experience. It wasn't an even distribution, but we did have examples from all sorts of experience levels. So in terms of results, we had the survey questions. So this is for the qualitative experience that we had of the participants. So that we had 4 questions. The first one is which system they thought provided better accuracy in terms of the direction of their shot. So the angle the ball then goes when they hit it. So you can see a lot of people answered 3, which is right, that they didn't really care which system they thought actually did better. But if they did care, they preferred the putter, which is interesting because, the moment of inertia around the vertical axis, the twisting axis, isn't really higher than a controller. But the interaction with the ground, we think, actually could affect that. So the second question is the same thing, but for distance. So which of the two systems they thought better provided accuracy for the distance of their shot. And this, a lot of people did care. And if they did care, more of them preferred the putter scenario. And we think this is because, of course, as I said before, of the extra mass, which kind of acts like a damper, and so they can have more accuracy in their shots. The third question is which one they preferred, and this is really strongly in favor of the putter. This is just which one they enjoyed using more. And then the last question was not quite as clear, but people did think that the putter was a little bit easier to use. And obviously, we expected that they would think it's easier to use because it matches what a real club would be like, and so they have a kind of a reference to go off of. So here's the raw data, basically, for the 150 centimeter distance. As you can see, these are just the final positions of the ball. And at 0, 0, that's where the target is. So as close to that is better. So in the real condition, they're pretty closely tightly packed around the center. And also in the putter condition, it's also more tightly packed. But the controller condition is a bit more spread out, as you can tell. The performance was a bit worse. Important to note here is that the scales of the axes are not square, so the vertical axis is a lot more spread out. This is because the angle of the shot was generally more accurate than the distance of the shot. Here's the same thing for the 300 centimeter distance. As you can see, again, the controller condition was a bit more spread out than the putter condition. And the same thing for the 600 centimeter distance. Once again, you can see that they start getting more spread out overall because, of course, it's harder to hit a ball accurately at the distance. But the putter condition is still a little bit closer packed. So here's that same data in the form of a bar chart, where you can tell the most important thing is that the blue bars are lower than the red bars, which means that the putter condition is more accurate than the controller condition. And significantly so at the 150 centimeter and the 600 centimeter distances. At the 300 centimeter distance, it wasn't significant, and we have a few theories as to why that might be. If you look at the difference in the bars, you can see the red bars are actually not linear, so it kind of increases more significantly at larger distances. So we think maybe the controller condition is not as linearly dependent on the distance of the shot as the putter condition is, where the blue bars are a bit more linear. And also the field of view of the headset matches the 300 centimeter distance nicely, so that, or not nicely, so that if you look at, you can see both the ball and the hole at the same time in the 300 centimeter distance if you align it properly, but then both are at the edges of the headset. So maybe there's some distortion that's happening there. We don't know exactly why that may be. And also really cool to see is that the real condition and the putter condition on the 150 centimeter distance are very similar, which means that our performance in the putter condition is pretty close to real life, which is great. So this is the same chart, but split out into the two groups that we put the people into. So the groups that tried the controller first are on the left, and people who tried the putter first are on the right. So here you can see the learning effect. So as people used the system, they got better at it. They got better at golfing, maybe. They got better maybe just at the system, but it's definitely an effect that we can see. So on the first condition, the putter is better overall. So that also adds to the effect. So the two effects are working together, and so you can see there's a much greater difference between the bars. But on the right side, the effects are working against each other. But interesting to see here as at 150 centimeters and at 300 centimeters, if you look at the average of the two bars, that's lower than the average for the left side. So the right side is lower than the left side. So the overall performance in the putter controller condition is better for those distances than it is for the controller putter condition. And so this is kind of cool because we think that might be because the putter condition teaches the people how to use the putter properly because they have to hold it in the right way. And maybe it's a better learning experience. So when they use the controller, they're maybe more inclined to rotate their wrists to kind of like flick the putter. And when they actually use the putter, they can't do that. So using the putter teaches them to use the controller better, possibly. And here you can again see how the controller condition is not quite as linear as the putter condition in terms of distance. So going back to our hypotheses, we can see that the putter will be preferred. That hypothesis was confirmed. Definitely people strongly preferred the putter condition. So our second hypothesis was that the putter will be more accurate. And this was also confirmed overall. At the 300 centimeter distance, it wasn't significant, but we explained kind of why that might be. But overall, it definitely was more accurate. And so our third hypothesis was that the putter will be more correlated with real-world performance. As we saw in the graph, the real-world performance and the putter performance were pretty similar overall for all participants, but we didn't find that the performance in the real world would, for a single participant, would better predict their putter performance than it would predict their controller performance. So we thought that a person would be better, the putter performance and the real-world performance would be more similar to each other than the controller performance for a single person. So we didn't find that. It wasn't significant. But we think it might be, we could maybe with a larger study or with more expansive conditions, because we only had the 150 centimeter distance in the real world because we had limited space. Maybe we would see something different there, but we're not sure. So if you notice during all our simulated worlds, we always had flat terrains. And in a real putting environment, you would have, in like a golfing environment, you would have terrains that aren't completely flat. And so the reason for that is that sloped terrains are really hard to see, especially variable slopes like this, in the headset for some reason. So as you can see on the right, the two images, they actually have the exact same slope, but one of them has a texture on it that kind of gives you a grid so you can see it better. So in the headset, of course, you'd have a stereoscopic view, so you could see it maybe better, but it's still really hard to see. So we think maybe the problem relies in the resolution of the headset, so we tried some higher resolution headsets, and the problem did seem to get a bit better, but it was still a problem, and so it was still really hard to see the slopes. One way to solve this, perhaps, is using feet, virtual feet, that would then be flat across the ground, so you could better align yourself with the slope. That's an interesting thing, is that a lot of people, when we performed the study, they commented that they would like to have feet, their virtual feet. They want to see their feet to align their shot. That could be something that we might work on in the future. Another thing that we would work on in the future is other tools in sports. So using this similar concept, knowing that a higher mass or having other utilities of the tool could be very useful for increasing performance. So here we have a tennis racket that also has an Oculus remote attached to it pretty firmly. So the same attaching mechanism could be used for any sort of tube that we used for the putter, so perhaps a billiards cue or something like that. And maybe a baseball bat would also be pretty interesting to work on. All right, thank you. If anyone has any questions, I'm ready for those.
Okay, so there's plenty time for questions. So are there any questions?
Hi, Jan Borges from RWTH Aachen University. I really like this, and one thing that I thought maybe there's even more to find in the data than you were telling us now was in the plotting of the final distances from the target. Because if I understood you correctly, you did ask people about their preference separately for direction and distance, but I didn't see a quantitative analysis of the user's performance split into direction versus distance. And my guess is that there could be something there that's interesting to tease out of the data, or maybe you need more samples to see it. But essentially, the shapes of these dot fields could be an interesting thing to look at. Have you started analyzing these in different, like separately, or wasn't there anything interesting, or?
Yeah, in the data in the paper, we did look at the differences in distance versus in the angle of the shot. So we did analyze the significances separately. I don't think we found any significant differences between those two, so they kind of came to the same result. They both had the same effects. Maybe if we had more data, we could find differences between the angle and the distance. But I think they had the same effects in terms of differences between controller and putter and that kind of thing.
I think especially with relation to the real data for those other distances would also be really interesting.
Yeah.
The second thing that, if I can ask another one, was if you do this kind of putting, what you were mentioning towards the end, the position of your feet is kind of the first thing that people teach you, that you really need to make sure your feet are aligned sort of to be parallel, like your tips of your feet are aligned in parallel to the direction, the vector to the hole. Mm-hmm. And I'm thinking it must be a major sort of challenge to do good putting without seeing those. I think that's really almost creating an experience that is not really like the real putting at all if you can't see your feet.
Yeah, so that's definitely an important thing to work on. But current systems, if you want to have a virtual system that is a golf simulator of some kind, then generally this is what you get at the moment without adding a lot of tracking. So that's definitely something we want to work on. But the one thing we added here was the putter as the prop.
And then finally, maybe what you were saying about slopes, I think what you typically see people, what they have to do if they want to understand the slope is they really change their point of view a lot. You'll see people looking at the slope from all kinds of different angles, because it's hard to see in reality too. So we really need to walk around, look at it, like get down on your knees, whatever, to figure out what the slope actually is along the way towards the hole. So that might be something to consider if you want to study slope terrains, to actually have give people the ability to move around and look at it from different angles too.
Yeah, in our simulation they can. So when we were trying it out, we definitely did do that. So even when you are close to the ground, you're putting your head close to the ground, it's still really hard to see. And there's some other things that we could try, some sort of maybe differences in the shaders of the actual material and stuff like that. So right now we should have a textured, a bump texture on the plane. But it's a lot harder to see than in the real world, even though it is pretty hard to see in the real world.
Thank you.
Okay, Frank, you had a question? It's gone, or? Okay, so.
So in the video, it appeared like the virtual prop was moving just in one dimension. It was sort of held straight up and kind of putted like this, right? Did I miss that, or was the angle of the putt shown in VR as well?
It's fully tracked. So wherever the putter is in the real world, that's where the virtual putter is. So you can just grab out your hand and it'll be there. Yeah.
Thanks.
Did you validate the accuracy of your physics simulation? Because in my experience, very often many game engines and so on, right? They just try to make it look believable, but it's not physical correct. So can you comment on that? Because just if I think about the ball, right? Maybe the game engine just considers it like a sphere, but really a golf ball has many bumps and so on. And that probably significantly changes the friction and things like that. So.
Yeah, definitely. We definitely did consider that. So we customized the physics a bit, not just, we used Unity 3D for the simulation. But we didn't just use the default physics simulation for the ball rolling effect. We did change the speed at which it slows down, especially a bit non-linearly near the end, because the actual bumps of the grass are really significantly affecting the trajectory right as it slows down. So that we noticed in the real world, and so we calibrated the rolling speed in the real world to the rolling speed in the virtual world. Well, other way around. But so what we did is we hit a ball in the virtual world and the real world at the same time with the same stroke, and then just measured the distance to calibrate that properly. Okay, that way, it's not maybe correct to a grass environment, but it's correct to our carpeted environment that we had in the lab, which we compared it to.
Hi, I was wondering, you talked about the importance of mass, and I was thinking about the contact dynamics and the swinging of the club. You probably feel the force and the inertia, and that's a longer duration event than the contact dynamics, which are transient. And I was just wondering if you looked at, in the haptics community, people have done some work with looking at skin stretch and trying to create the illusions of force, either in tool handles or things like that. And I wondered if you thought about including that in your controller.
So in terms of simulating having a prop that you don't actually have in your hands?
Yeah. The example I'm thinking of is I think Allison Okamura and Will Provancher did some work with a virtual environment where you could basically hold a handle and have the feeling of putting force on the end of the handle, and it was all about skin stretch in the palm of the hand that fooled the body into thinking there was force on the handle. And I just wondered if you talked about the importance of mass, and I agree with you, and I'm just wondering if you thought about trying to create that mass illusion with some other kind of actuation.
Yeah, I personally haven't looked into that, but that definitely seems like if the important thing here is that the mass is definitely one of the important things, I guess. So the other effects are like the putter touching the ground, which we also thought was really important for this task. But definitely, if that can properly simulate the mass effect, then it could be worthwhile.
Hi. Two-part question. When users switch between the putter and the Oculus controller, did they tend to one-hand the Oculus controller? And did you notice a difference if, even if they couldn't put their both hands on the Oculus controller, were they more accurate?
We asked them to use both hands. So basically, they were holding the controller in one hand, and they kind of put the other hand on top like this. So that's kind of the position we asked them to have. It's just for a bit more consistency. Yeah, but they definitely we did notice a difference, as I said before, in terms of like how they used it. So they used their wrists a bit more with the Oculus controller if they did that one first, especially. So there was a bit difference in how they used it, like that.
Yep.
Were you able to find any effects for people who had golf experience in the past? Any difference between them and others? And in particular, I'm thinking that the putter with the controller might have a slightly different mass signature than the naked putter, and that they might find that if people had golf experience, they might find that noticeable.
Yeah, so I don't think we had quite enough people to really make those kinds of conclusions. Since of our 20 people, not that many had a lot of experience with golf. So I think maybe with more people we could look into that a bit more, but we did not find any significant difference from our people that would show significant difference that would show that they would prefer the putter more, for example, or something like that. So we didn't see any differences in how they used it.
Okay, are there any further questions? So I would have probably the last one. So what do you think how you could somehow transfer these results you look at a very specific piece of physical thing, right? The putter is a really specific thing. So do you think that you can transfer somehow the results to other kind of scenarios? Because just using the putter for something other kind of interaction seems to be probably a little bit odd. So there might be people using putters for other things than playing golf, but that's probably not feasible. Do you have any kind of...
Yeah, so other props that have a similar mass or utility, like the utility between the floor and the putter, could be useful. So I mentioned billiards cue, that kind of interaction between the table and your billiards cue could be really useful. So we think anything with a large mass, with a significant difference between just a handheld controller and the prop itself would be important, would be similar, find similar results.
Okay, good. So thank you very much again. Thank you.